Okay, so let's do an exam style question now. We've got a 2 kilogram ball dropping from a height of 5 meters. So here's our ball here, and it's 5 meters from the ground. 5 meters. Calculate its speed as it is about to hit the ground. So we know that speed is velocity, and height is in meters, and mass is over here. So we've got mass, we've got height. At this point, you should be looking at your two equations. Energy equals half mass times velocity squared. And the other one you know is gravitational potential energy, which is mass, the gravitational field strength, and height. So this is where you should be thinking, this is what I need. However, I've only got these two values. So at this point you might be able to see that you can calculate the energy of the gravitational potential over here. We can definitely do that, but we need this equation at some point because this is the one with the velocity squared. So this is where the sentence "assume that energy is concerned" is a key sentence. So remember the conservation of energy rule, that energy is always conserved. It cannot be created or destroyed. It can just be transformed and transferred. So what that means is gravitational potential energy equals the kinetic energy of the ball. So that means we can go ahead and calculate the gravitational potential energy, and it will equal the kinetic energy. And once we have kinetic energy, we'll be able to calculate the velocity. So let's go ahead and start with the gravitational potential. Gravitational potential equals mgh. So mass is it's a 2 kilo ball. Gravitational field strength is 10, and the height the ball fell from was 5 meters. So we have 2 times 10 times 5. So we have 100 joules of energy being released. So because we've said that gravitational potential is equal to kinetic energy, because energy, we're assuming that energy is conserved, then we know that kinetic energy is also 100 joules. So the 100 joules gravitational potential energy that was in the ball before it fell has been converted to 100 joules of kinetic energy at the end of its fall. So to get achieved for this question, you need to recognise that the ball had gravitational potential energy before it fell, and this was converted to kinetic at the end of the fall. So that's that point there. So even if you made an error with the calculation, you could still get an achieved if you use the correct formula and recognise that kinetic energy is converted from gravitational potential, or that gravitational potential equals kinetic energy. And if you are able to do the calculation with the correct units, that would be a merit. For excellence, you need to calculate the velocity of the ball, so the speed at which the ball is about to hit the ground. So the only formula you can use for that one is EK equals half m times velocity squared. So this is where you're going to need your triangle, because you need to get velocity squared by itself on one side of the equal side. So doing your triangle, half mass times velocity squared shows us that we need to divide the energy by half mass in order to get the velocity squared. So go ahead and write that out in full. Energy divided by half mass, which equals 100 divided by, the mass was 2 kg. So velocity equals 100 over 1 equals 100. But don't forget, this was velocity squared. So we're almost there, but not quite. We have to undo the square, which means we have to take the square root. So make sure you show all your working. And you might know that off the top of your head. 10 times 10 is 100, which means the square root of 100 is 10. And don't forget your units, 10 meters per second. So if you can do that last step, which was finding the velocity, and including your units, that is where you can get an excellence.